Joined now in the studio by Dr. Loïc Henriet, who's Chief Technology Officer and Managing Director of Pasqal, a leading quantum computing company. Welcome to the show.
Thank you. Thank you very much for having me.
So walk us through the mission behind Pasqal, especially to those people who don't deal with quantum on a daily basis.
Yeah, so at Pasqal, we design, we build, and we operate quantum computers. Quantum computing is a novel form of compute that is complementary to classical HPC and AI. With quantum computers, you will be able to solve problems that cannot be solved using traditional machines. So, for example, in drug discovery, modeling of new materials, and so on.
Look, you've already had successful deployments across 3 continents now. What have you learned from those early experiences?
Yes, indeed. So we have machines here in Europe, in France, in Germany, but also abroad. One in Canada, another one that was inaugurated in Saudi Arabia in May, and last one in last week actually in Italy. So we are learning a lot from those deployments. Our mission at Pasqal is really to take this technology out of the lab and deploy it in the field for our users, our partners to be able to use. So it's a fantastic journey to take this technology out and to generate usage, recurring usage on this technology.
Now I do have to ask you, we have to talk about this path to fault-tolerant quantum computing. We're hearing that now. Explain to us what FTQC really is.
Yes, thanks. So the current machines that we have, we operate them with physical qubits. Those physical qubits, they are prone to errors, meaning that each computation that we run, you can have a few errors that accumulate, and it limits the ability of the computation that you are trying to run. It's still very useful for specific tasks, but the full value of quantum computing will really be at this FTQC stage where we can correct those errors. Just pretty much like in the classical computer, you really need to correct in real time the errors that accumulate to have a faithful result at the end. And over the past few months, we've seen a great progress across the board on this FTQC era in laboratories, in academic labs, but also in companies and at Pasqal.
What are the first industrial use cases we're really going to be seeing with logical qubits?
So the things that we've done at Pasqal is to use those logical qubits, error-corrected qubits, to solve differential equations. Differential equations, they are ubiquitous in many fields of industry. It can be useful in financial services, can be useful also in fluid dynamics to model the flow around an airplane, for example. It can be useful also like in battery design and so on. So solving differential equations is a very broad topic, and we were able to solve those equations using logical qubits. And when we did that, using logical qubits, we were able to reach performances that are better than with physical qubits. So error correction is really kicking in and helping us achieve the best outcome.
Let's take a look ahead. Let's imagine it's 2030. What can we realistically expect from quantum computers then?
So I think that 5 years from now, we will be pretty much at the stage where AI is right now. Meaning that we have already achieved the first computational breakthrough, and specialist users can use those machines to provide value now. But it's not still a mainstream technology. And what we can imagine that 5 years from now, usage will ramp up and we'll have an ecosystem of companies that are building on top of the hardware so that it can really kick off and have a maximal impact on society at large.
Well, looking forward to what 2031 brings for us, and it's a pleasure. Thank you for joining us here on the show and breaking down quantum computing for us. Thank you so much, Loïc.
Thank you very much.